We're going to get into the second part for me of 1-5, which is talking about angle relationships, and we're going to get into looking at perpendicular lines today and how that helps us when we're trying to solve for missing angles, because those angles or the missing parts of angles end up being complementary. And so we learned about complementary in the first part of 1-5, and we're going to apply it today to perpendicular lines. So when you have lines that are perpendicular, when they intersect, so line AC over here and line DB over here intersect, and they're perpendicular because they make a 90-degree angle. So to be honest with you, all of these angles are 90-degree angles. They only had to mark one, and we know that. But you could say that those lines are perpendicular. Let's jump down straight into the examples. All right? So I'm going to the example right here, and it says find x so that ray, all right, DZ, which I actually don't like. I think that should be named ray ZD, starting at that vertex Z right there, but it's okay. And ray ZP are perpendicular. The bottom line is, if it was a line, this would still work. All right, so here's what you got. You know this is a right angle because we're trying to show or solve for x to show that they are perpendicular. So let's start with, all right, we're saying they're perpendicular. Now make the math work. Well, I think you learned when we started looking at angles that in 1-4 we did angle bisectors where you had a ray that split that angle in half. So here we got ray ZQ. Well, you can tell it doesn't look like it splits it in half. Now, we can't always judge that from the drawing, but here we don't know if ray ZQ is a bisector, but what we do know is that these two angles combine to make a 90-degree angle because we're trying to show that those rays are perpendicular. So I'm going to take this angle right here, I'm going to add it to this angle right here and set them equal to 90. All right, so it's actually pretty simple. So here's what it looks like. Angle DZQ was 9x plus 5. Angle QZP was 3x plus 1, and I'm going to add those together and set them equal to 90. And you're like, well, why can we do that? Because we know that when you combine them, it's 90 degrees. They might be equal. This might be a bisector once we do the math. I don't think it is, but we know that we can combine those angles and set it equal to 90 because they're complementary, or they made, we had a perpendicular 90-degree angle there. All right, here we go. Combine like terms. I always like to use different, like I'll underline like terms, circle the constants maybe, or put a box around it, or triangle, something to separate. Combine your like terms. Simplify the problem first. 9x plus 3x is 12x. 5 plus 1 is positive 6 equals 90. There's our algebra, right? Should be in good shape. Let's keep tracking this thing. Here we go, minus 6 from both sides. I get 12x equals 84. I don't know if y'all like putting the line here or separate it, however you want to do it. It's up to you. Divide by 12, x equals 7. That's all we were looking for. Said find x. Here we go. If we plugged x in as 7 for both of those, we would add them up and we would get 90. We don't have to do that right now. But it's kind of what's going on. The textbook groups the angles together over here in parentheses. I'm not a huge fan of that. It's okay, but there's no need for those. We're adding those angles, all right? So it should be able to stay. It should be able to stay fine. All right, let's go down. Let's jump into the exercises. Here we go. Find the value of x and y so that line NR is perpendicular to line MQ. So there's NR, there's MQ. We want these to be perpendicular, so they put that right angle right there. Now, there's one mistake that I see when people get this. They go, oh, and to be honest, when we get a little bit further into vertical angles, people will try to set this up and go, oh, well, I know that 9y plus 18 and then that 5x plus x, that those are vertical angles, and they do both equal 90. They are congruent. But here's the deal. With where we're at, we don't want very different variables at all in this problem. You're like, well, we can get y by itself. Sure, in algebra, whenever you're trying to find, the slope and y-intercept of a line, we can do that. This is not what we want to do here. We want to solve for a variable, either the x or the y, and maybe that helps us solve for the other one, but we don't want to have two unknown or two different variables at that point. All right, so here's what we do know, and I already said it. We know 9y plus 18 is 90. If this is going to be perpendicular, then all of them are perpendicular or 90-degree angles, right? So we should be in good shape. So my first one, I'll just do the y. I saw it first. 9y plus 18 equals 90. Right here, there's a 90-degree angle, even if it's not drawn. Pretty quick algebra, minus 18 from both sides. All right, 9y equals 72. Divide by 9, and y equals 8. Not too bad right there. That's all we got to do. We had to find y, yes. Now we got to go find x. Again, doesn't really matter the order here. They're kind of independent of each other to solve. Sometimes you need one to find the other. You got to find that value, but it's all right. Okay, here we go. I know that this 5x angle and this x angle have got to be 90 degrees, right? They're complementary. We're going to make it where it's perpendicular. So I can take both of them, 5x plus x, and I can set that equal to 90. That's kind of the theme of the day from the algebra. Combine like terms, 5x plus x makes 6x. That equals 90. Divided by 6, x equals 15. There we go. There's our two answers, x and y. To be honest, pretty simple. Man, pretty much the rest of them work the same. I'm just going to go ahead and do number 3. It's right there. Again, if you have questions, if you're watching this, shoot me an email. Remember, online tutorials. My Google Meets is open Tuesday and Wednesday morning at 10:40. You can get on there and ask for help. Let's go to number 3. All right, so they tell us the measure of EBF right here is 3x plus 10. So this angle right here. Usually I draw the angle sign, but I'll point to it. Then we know that DBE is x. So down here, that little bitty one, just x, right? Everybody see where it's pointing? I'm going to erase those. Don't want you to get confused, but that's what we're talking about. So they tell us that ray BD and ray BF are perpendicular. So we know that that's a 90-degree angle between those 2 points. Find the value of x. Guess what we're going to do? I'm going to come over here, and I'm going to go x plus 3x plus 10 equals 90. It's perpendicular. It makes a right angle. Those are complementary angles. There we go. Combine like terms. 4x plus 10 equals 90. Minus 10 minus 10. I'm going to go over here to the right. 4x equals 80, because 90 minus 10 is 80. Divide by 4. X equals 20. There's the value of x. Pretty simple. Pretty simple stuff. Okay, I actually want to go back and revisit one of the problems that were in your part 1 notes for 1.5 that I didn't do when I made this video. So I'm flipping my paper over, and I'm going to do number 8 right here, because we've got to start looking at word problems. Very, very good from a critical thinking standpoint. So here's what we got. Read it. I always, if you can draw a figure to help you, maybe we do it, but find the terminology and see what it means. Find the measures of 2 complementary angles. We just dealt with that today, didn't we? What do we know about that? Hey, complementary equals 90, or it makes perpendicular rays or segments or lines. But these 2 complementary angles have a condition. We want the difference of their measures to be 18. So key word here, hopefully for you, is difference. And you learned when you were younger that difference is subtraction, right? So somehow we need to be able to subtract these values, and there'd be a difference of 18 between our angles. Well, let's look at this. All right, so if I'm going to have complementary angles, I'm just going to draw rays. I'm not even going to name them. I don't know if these are equal or not. Actually, I do. If one of them has a difference of 18 from the other one, they're not going to be the same, right? So I've got a ray coming, doing something like that. So where word problems are tricky is you've got to be able to start with something you don't know, right? We don't know the angle. Well, I'm going to put what I don't know. I know that that angle right there is x, because I don't know what it is. It's an unknown, but that's our starting point. And when we can start there, we can actually write what this angle is. What do we know about this bottom angle right here? We know that it is smaller than this angle by how many units? By 18, right? So whatever x is, I know that this is that angle with a difference of 18. Well, what does that look like? It looks like that. One angle is x, one angle is x minus 18. We know that this is 90, right? We've said that these 2 angles are complementary. There's your algebra problem. Now you look at it and go, well, that's as easy as the stuff we did in the notes today. And you would be exactly right. Something that you can do, let me move this up a little bit for you, for sure. All right, here we go. Combine them. I've got x plus x minus 18. There's our angle, and the angle that's 18 smaller than that. And what do those equal? They're complementary. It equals 90. Combine like terms. 2x minus 18 equals 90. Add 18 to both sides. 2x equals 108. Now, Sometimes there are people go, well, we can't have two angles equal 108. They don't equal 108. They're complementary. They equal 90. The algebra has set this up to where right now the value in there is 108. You just keep doing the math. Divide by 2, and we get x equals 54. Guess what this angle right over here is? It is 54 degrees. Now, should the math work for me to find this other angle? Yeah, what would we do? I'd take 54 and I would subtract 18. Well, what is 54 minus 18? Well, that's 36. Does 54 and 36 make 90? Yeah, when you add them together, I'm pretty sure it does. So it's really not that hard. It's all about setting up. You had to know complementary angles. You had to know what difference was. You had to know that the angles had a difference of 18. And we set it up and we solved. Very doable. You're each capable of that. All right. We will work through some word problems together. All right. Again, if you have questions, shoot me an email. Get on online tutorials. If you're watching this and you have me in class, stop by anytime. I'll be happy to help you. Thanks.